In this video, we will limit our scope of sampling application to DMAIC for easy understanding. So, as an invisible observer, if we walk through a process where a DMAIC improvement project is applied, we will come across some common situations where data and its accuracy is very important. Those events will help us to correlate when, where and why sampling would be useful. In DMAIC, define phase is all about defining and quantifying the problem and the expected improvements. Now, once the basic expectation is accepted by all stakeholders, the effort goes into understanding the current process and studying the current process data to assess how capable the current process is. For collecting this process data, one of the common questions is how much data to collect. And here, sampling helps the teams. Once the process is well understood and the data is collected, teams work on establishing the current process capability. They find the root causes for the problem in hand, and data is used for confirming the validity of such causes. And then solutions are evolved. Here, for this validation of the root causes, teams need to mine or collect data. Again, the same question repeats: how much data is going to be sufficient? In DMAIC, solutions evolved are implemented in a timed manner. DMAIC projects are popular as the methodology ensures that post-solution implementation, teams need to statistically validate if there is a significant improvement in process, if this improvement is going to be long-lasting. Here again, it's very important to know a scientific method that tells how much data to collect. Even in an improved process, once all the solutions are implemented, it's very critical to monitor the quality. Again, the question is when to sample, how much to sample. In all these situations, sampling is extremely useful. In all these situations where one wants to be sure that the collected data must be representative of the problem, collected data should be just adequate such that the time and effort is justified. Sampling becomes very important. In the sampling journey, the first and most important part is to select the right sampling method. And these methods depend on the type of data we encounter in the project. We may have heard about the common data types of continuous and discrete nature. Now, just for our understanding, temperature, for example, is a continuous data, as it can record the actual and exact state of a hot or cold body. So we see such data in decimals like 36.1 degrees Celsius. Discrete data, on the other hand, it's a count data, like number of people in a room who have fever. Such data is never expressed in decimals. It will always be in whole numbers. And this data type regulates the choice of sampling method. One more aspect which is critical to sampling is the confidence on the sample we have collected. Only if our confidence level is high, we will believe the sample data analysis. In stats, this confidence is referred to as confidence level, and normally it is taken at 95%. This means any analysis result we derive from sampling, we would say we are 95% confident that the result is going to be accurate.